Alright, I hope you guys are having a great evening. Today, this video, we're going to really focus on a review of exponent properties and simplifying exponential expressions. We have about 7 different properties that I want us to go to and be able to review with the general rule and the example that goes with it. And then we're going to go through 4 different examples at the end of the video that really combine a lot of the properties. And I think you guys are doing fairly well with being able to keep each property separate, and when you're only having to work with one property at a time, but it's when you're having to do multiple properties that it gets pretty challenging. Hopefully you enjoyed that theme music to start us off, but let's go ahead and get going here with a review of these properties. The first one that we're going to look at is called the product of powers. Remember, I will never ever ask you to name all of the properties, but you do need to know what they look like and how to apply them. The product of powers, the general rule here tells us if we have 2 exponential expressions that have the same base, b to the m power times b to the n. You'll recall the base here on both of these is b. If you multiply them, you actually add the exponents. It becomes b to the m plus n. So this example over here, it will become x, well, 5 plus negative 3 plus 14. 5 plus negative 3 gives us 2. 2 plus 14 gives us 16, so x to the power of 16. Our next property here is the power of a power. So here we already have an exponential term like a to the x, and it's raised to another power, the whole thing raised to the y. Power of a power tells us that you actually multiply the 2 exponents here. It becomes a to the x times y, whatever the product of that would be. For this example, we have x to the 5th to the 4th. That's the same then as x to the 20th. One thing I also want to encourage you, if you can't always remember the shortcut here, like to multiply 5 times 4, think about expanding it. X to the 5th to the 4th really means x to the 5th 4 times. We have 4 factors of x to the 5th. One more here, x to the 5th. So now we have x to the 5th times x to the 5th times x to the 5th times x to the 5th, which again gives us x to the 20th based off of our product of powers rule. We have 5, 10, 15, 20. All right, moving on to power of a product. Here we have 2 things being multiplied, or it's still a monomial, but 2 different terms in here being multiplied, all raised to the m. This becomes a to the m times b to the m. Both things are raised to that power of m. Here, x to the 5th, y to the 3rd, using both this property and the power of a power, it becomes x to the 30th, y to the 18th. We multiply the exponents here. I kind of look at this one as the distributive property with exponents because everything inside the parentheses is affected by the exponent on the outside. Last property on this page is the quotient property. Again, as long as we have the same base, x to the a over x to the b, we can simplify this by subtracting with division. It becomes x to the a minus b. So looking at this example, the 3 and the 2 are different bases, and it's already simplified, so we can't do anything with 3 halves. But then we have x to the 5th and x squared. Using our subtraction, that gives us x to the 3rd in the numerator. We have 3 more factors of x in that numerator. All right, let's take a look at a couple more examples with properties, or 3 more properties here. The next one's called quotient of a power, which says x to the a divided by x to the b, all to the power of c. Well, that just tells us that everything is raised to that power. It becomes x to the ac all over x to the bc. And with this example here, it becomes 3 squared x to the 6th all over y to the 10th. Remember, always pause this if you need some extra time to write these examples down. The next one deals with negative exponents, x to the negative a. Anytime we have a negative exponent, we want to think about the reciprocal of the positive exponent, which becomes 1 over x to the a. And now that we moved it to the denominator, the a is now to a positive exponent. It was negative. This example, it's 3 times x to the negative 5th, or 3x to the negative 5th. Here, the only thing being raised to the negative 5th is the x term. So 3 must stay in our numerator. X to the negative 5th gets moved to the denominator, and it becomes positive because we moved it. So it's 3 over x to the 5th. 3 divided by x to the 5th. The next one, 0 exponents. Any number to the 0 power is always 1 as long as that number does not equal 0. Okay, so a to the 0 power is equal to 1. Looking at this expression, it's 5x cubed, y to the 5th, all to the 0. Since everything in this is being raised to the 0 power, we can simply call this 1, again assuming that x and y both are not 0. All right, moving into this first example here. Okay, with this first example, we have 5x squared 3y to the 3rd times 2x to the 4th y, all raised to the negative 2nd. The first thing I want us to look at with this example is taking this second monomial term and raising it to the negative 2nd. So we're not changing anything with the first. You can just take it out of the parentheses. It becomes 5x squared y cubed times everything being raised to the negative power here means that we have 2 to the negative 2nd, x to the negative 8th, y to the negative 2nd. Now you have a couple of options. You can either take care of these negative exponents by moving them into a denominator, or we can look at the terms that we have that we can combine. For example, we have powers of x's that we can combine and powers of y's that we can combine. Either one works. So I'm going to combine the powers first. We still have a 5, and we still have a 2 to the negative 2nd. I'm not going to do anything with those. This is x squared and x to the negative 8th. If we remember, we add the exponents here, so it becomes x to the negative 6th, and y to the 3rd, y to the negative 2nd. When we add those, it becomes y to the 1st, or simply y. Now, let's take care of these negative exponents. The 2 to the negative 2nd and the x to the negative 6th will get moved to the denominator. We're left with 5y in the numerator over 2 to the 2nd, x to the 6th. And we can finally simplify this to 5y over 4, x to the 6th. Okay, I'll keep that up here, but still look at our next example. With the next one, we have 2k to the 4th, m to the 3rd, n, divided by 4k to the negative 2nd, m, n to the 5th. With this, I'm going to suggest that we take care of just this negative exponent first. That's the only one that has a negative exponent, so it's the only one that we can move, really. This then will become 2k to the 4th, m to the 3rd, n, and this k to the negative 2nd gets moved up here and becomes k to the 2nd. We're still multiplying everything. Down in our denominator we have 4, the k to the negative 2nd got moved up, we still have an m, and we still have an n to the 5th. Now I'm going to look at combining my k's. We have 4 factors of k here, we have 2 factors here. This gives me 2k to the 6th, m to the 3rd, n, all over 4 m n to the 5th. Last step really is to look at things and group them as 1. We have 2 over 4. We know that can simplify to 1/2, so it'd be 1k to the 6th, or just k to the 6th. K, it doesn't have anything that it can simplify with. We have 3 factors of m up here, 1 factor down here. That leaves us with 2 factors of m in the numerator. We have 1 factor of n in the top. We have 5 factors of n in the bottom. Don't forget we also had the 2 down here from the very beginning. 2 over 4 became 1/2, and then that gives us 4 factors of n, with n divided by n to the 5th. So that would be my final answer of k to the 6th, m squared, divided by 2n to the 4th. All right. Pause it or rewind it if you need to look at those examples again. The next two, I want you to jot down in your notes and try on your own. We have 3x to the negative 1st to the negative 3rd divided by 3x squared to the negative 2nd, and t to the 4th u v to the negative 2nd over t to the negative 3rd u to the 7th. Go ahead and pause the video, try them on your own, then push play when you think you're ready to take a look. Okay, hopefully you were able to get started on these, or at least take a look at them. What I'm going to do with this first example is get rid of the negative exponents at the very beginning. So I'm just going to move this whole bottom term, which is 3x squared, to the top, and then this negative 2 becomes to the positive 2nd. Also move the whole top term from the numerator, which was 3x to the negative 1st, move it down. We didn't do anything with this x to the negative 1st, we changed this negative 3 to a 3. Now moving forward from here, this becomes 3 squared, x to the 4th in my numerator. Down here we have 3 to the 3rd, x to the negative third, because negative 1 times 3. Now, looking at simplifying these, 3 squared and 3 to the third, that's going to be 1 extra factor of 3 down in our denominator. And we have x to the fourth over x to the negative third. You can use your subtraction rule, which would say x to the 4 minus negative 3, or you can think of moving the x to the negative third to the numerator and it becomes x to the third. Either one work, and they leave us with x to the 7th over 3. X to the 7th over 3 for our final answer. The last example here, again taking care of my negative exponents first, would give me t to the 4th u, those both stay up, times t to the 3rd, this one would be moved up, divided by, we still have u to the 7th, and then v squared gets moved down here. So this one simplifies to t to the 7th u over u to the 7th v squared. We have a factor of u here with the 7 factors of u down here. Then we can subtract. That gives us t to the 7th over u to the 6th v squared for our final answer here. All right, hopefully you're feeling a little bit better with exponents, simplifying exponential expressions. If not, make sure you get some extra practice with these. But come in tomorrow ready to go with any questions that you might have before your quiz on Wednesday. Thanks and have a great evening.